What is a race condition? Beginner level. Introduction. Modern programs often perform multiple tasks at the same time using techniques like multithreading, concurrency, parallel processing. In such systems, multiple threads or processes may access and modify shared data. If these operations happen in an uncontrolled order, the program may produce unexpected or incorrect results. This problem is called a race condition. Race conditions are common issues in multithreaded and concurrent programming. What is a race condition? A race condition occurs when multiple threads or processes access shared data at the same time and the final result depends on the order in which operations occur. In simple words, race condition equals multiple tasks compete to modify the same data, causing unpredictable results. The outcome of the program may change depending on which thread runs first. Simple example. Imagine two threads updating the same variable. Initial value. Balance equals 100. Thread A. Balance equals balance plus 50. Thread B. Balance equals balance 30. If operations happen in different orders, the final result may change. Example scenario. Correct result should be 100 plus 50 minus 30 equals 120. But if both threads read the value at the same time, thread A reads balance equals 100. Thread B reads balance equals 100. Thread A updates. Balance equals 150. Thread B updates. Balance equals 70. Final result becomes 70. Which is incorrect? This happens because of a race condition. Example in programming. Example in Python. Simplified. Import threading. Counter equals 0. Def increment. Global counter. For I in range 100,000. Counter plus equals 1. Thread 1 equals threading. Thread. Target equals increment. Thread 2 equals threading. Thread. Target equals increment. Thread 1. Start. Thread 2. Start. Thread 1. Join. Thread 2. Join. Print. Counter. Expected result 200,000. But sometimes the result may be less than expected due to race conditions. Why race conditions occur? Race conditions occur because checkmark multiple threads access shared data. Checkmark operations are not atomic. Checkmark execution order is unpredictable. In concurrent programs, threads may interrupt each other during execution. Visual explanation. Example. Thread A means read value. Thread B means read value. Thread A means update value. Thread B means update value. Both threads operate on the same data simultaneously, causing incorrect results. Real-life analogy. Imagine two people updating the same bank account ledger. Person A reads the balance, $100. Person B reads the same balance, $100. Person A adds $50, $150. Person B subtracts $30, $70. The correct balance should be $120. But due to simultaneous updates, the result becomes incorrect. This is exactly what happens in a race condition. How to prevent race conditions. Developers use synchronization mechanisms to control access to shared data. Common techniques include 1. Locks. Mutex. A lock ensures only one thread can access a resource at a time. Example. Lock. Acquire. Hash critical section. Lock. Release. 2. Semaphores. Control how many threads can access a resource simultaneously. 3. Atomic operations. Operations that complete without interruption. 4. Thread-safe data structures. Special data structures designed for concurrent access. Example using lock. Example in Python. Import threading. Counter equals 0. Lock equals threading. Lock. Def increment. Global counter. For I in range 100,000. Lock. Acquire. Counter plus equals 1. Lock. Release. The lock ensures only one thread updates the counter at a time. Race condition versus deadlock. Feature race condition deadlock. Problem incorrect data results program stops progressing. Cause simultaneous data access circular resource waiting. Result unpredictable behavior program freeze. Race conditions cause data inconsistency, while deadlocks cause execution halt. Where race conditions occur. Race conditions often appear in multithreaded programs, operating systems, database systems, distributed systems, high-performance computing. Examples: updating shared counters, banking transaction systems, multiplayer game state updates, concurrent database updates. Simple definition. Race condition. A situation where multiple threads access shared data simultaneously, and the final result depends on the order of execution. Final summary. Race conditions occur when multiple tasks compete to modify the same data. This can cause checkmark incorrect program results, checkmark unpredictable behavior, checkmark data corruption. To prevent race conditions, developers use checkmark locks, checkmark semaphores, checkmark atomic operations, checkmark thread-safe programming techniques. Understanding race conditions is essential for building safe and reliable concurrent programs.